So the web graph is a way to succinctly represent these equations to come up with our importance scores. And it's circular logic. For instance, W's importance score right here is dependent upon Z's importance score, which is in turn dependent upon X's importance score, which is in turn dependent upon W's importance score again. And this is recursive logic, as we call it, and it requires us to solve a set of simultaneous equations. So if we just write out our equations again that we had last time, we had said that W is equal to Z over 3. We said X is equal to W over 2 plus Z over 3. We said that Y is equal to W over 2 plus X over 2 plus Z over 3. And we said that Z is equal to X over 2 plus Y. So we have 4 equations, 1, 2, 3, 4, and we have 4 unknowns, which is exactly what we need in order to be able to solve this equation. But what's nice to notice is that actually each of these importance scores has to add to 1. So we have to be able to add them all up and get 1. So we have to say that W plus X plus Y plus Z is going to come out to be 1 in the end. And the reason for that is that each of these are really probabilities. As we said, it's the probability that a user is going to visit a given web page. And so probabilities always like to sum to 1. So this is kind of a convenient equation to work with. So rather than working with each of these 4 equations, we can actually just work with 3 of them in this equation. And so the way that we want to actually go about solving this is in the least tedious manner possible. And so we'll try to be practical about the equations that we use. So the first thing we want to do is we want to pick a variable that we're going to solve for first. So we're going to say pick variable. And W and Z seem pretty convenient together because we have a simple relationship. We have that W is equal to Z divided by 3. So why not get all of the importance scores in terms of Z and then plug it into our equation that W plus X plus Y plus Z has to be equal to 1. And that's the way that we're going to go about this because it's the least tedious manner possible. And so now we have this relationship for W, so now let's try to get X in terms of Z only. So we already know that X is equal to W over 2 plus Z over 3, which is equal to, then since W is Z over 3, we have Z over 3 divided by 2, which is just Z over 6 plus Z over 3. And that comes out to be just Z over 2. So X is equal to Z over 2, W is equal to Z over 3. So then now we can go ahead and look at Y. And now we're going to be a little careful when we go and try to equate everything for Y. And the reason is that Y's equation involves each of the other variables. So we had said before that Y is equal to W over 2 plus X over 2 plus Z over 3. But we know from the fourth equation that Z is equal to X over 2 plus Y. And this equation is actually much easier to work with because we already know X in terms of Z. And so therefore we can just say that Y is equal to Z minus X divided by 2. And since X is equal to Z over 2, that's just Z minus Z over 4, which is really just 3Z over 4. So now we have each of these relationships. We said that W is equal to Z over 3. We said that X is equal to Z over 2. And we said that Y is equal to 3Z over 4. And since W plus X plus Y plus Z has to be equal to 1, then we have Z over 3 plus Z over 2 plus 3Z over 4 plus Z has to be equal to 1. And we can backtrack then and solve this for z, because now we have one variable in this equation, and we end up getting that if we add all these fractions together, we get that 1 has to be equal to 31 over 12 times z. It's kind of a messy fraction. And that means that z has to be equal to 12 over 31, which is 0.387. And so again, what that means is that there's roughly a 38.7% chance that we're going to be on page Z at any given time, which means that Z has an importance score of 0.387. So now we can use these other relationships to solve for the other importance scores. So we have that W is equal to Z over 3, which is just 12 over 31 divided by 3, which is 4 over 31, which is 0.129. So again, this is a smaller importance score. W has a smaller importance score than Z. We have that X is equal to Z over 2, which is 6 over 31, which is 0.258. And finally we have that Y is equal to 3Z over 4, which is 9 over 31, which is 0.290. And so even though we didn't make use of that third equation for y that we had before, if you go ahead and plug that in for y, so if you plug in y equals w over 2 plus x over 2 plus z over 3, you will get the importance score for y, so this equation will still match.